NRL is the Naval Research Laboratory method, and this method was developed by US Navy. So what they did, so they replaced the Caine's freezing ratio, a term called shape factor. So in this method, they are now replacing the freezing ratio concept with the term called shape factor. And in this method, very minimum calculations are required in order to find out the size, or you can say the diameter or the height of your riser. And what is the shape factor? So they have defined that shape factor equals to L plus W whole divided by T, where L is the maximum length of your casting, and W is the maximum width of your casting, and T is the maximum thickness of your casting, where L is greater than W, which is greater than T. Now you have to calculate the shape factor. And once the shape factor is calculated, the riser size is determined by using an empirical relation by the graphs. So they have, again, just like Caine's method, they have given their own graph. And in this graph, you can easily observe that on the x-axis, they have defined the shape factor values, and on the y-axis, they have given the volume ratio, which is the riser volume to the casting volume. Once you have this shape factor, which easily can be obtained with the length, width, and thickness of the casting, so that you have to draw a line. So suppose if you calculate the shape factor to be 16, so you draw a line. We should cut this graph, and then correspondingly here, you can easily obtain the volume ratio. In this method, the calculation is least as compared to the Caine method and Modulus method. And further, they have simplified their calculation in terms of the riser volume and the riser height. Once you calculate the volume ratio, from that volume ratio, and you have already this volume of the casting, the riser volume can easily be calculated. And now they have also drawn these different curves, which shows that this curve is for the diameter of the riser, which is having 12.5 centimeter. This is the curve for the diameter 15 centimeter. This is for 17.5 centimeter. This is the diameter of 20 centimeter. And lastly, this is the diameter of 22.5 centimeter. And they have also drawn two curves of H by D ratio equals to 1 and HYD ratio equals to 0.5. How this HYD equals to 1 is coming? So I told you that it is related to the optimal size of the riser. And if you minimize the area of the side riser, then from addition, you can obtain the value of this H by D equals to 1. And here also, in case of this top riser, this HYD ratio will be your 0.5 from the minimization of the surface area. And now from that the volume ratio and the volume of the casting, you will have the riser volume. And then easily you can plot, you can draw the line, vertical line, and it will cut different points. Okay. Now you will consider those points within these two lines, H by D equals to 1 and H by D equals to 0.5, because both the lines present the optimal size of the side riser and the top riser. So you will consider the lines, the points which are coming between these two curves. So it may cut any point. Suppose it may cut this. Currently, you can observe that you have these 2 points, 1 point, 2 point, and 3 point. So you will neglect this point because it is above the optimal size, this curve. You will consider these 2 points, like it is 10 centimeter in height. And here, I think it is somewhat 12.5 or 13 centimeter. So you can consider these two dimensions as per your requirement, as per the size of your molding box. And now they have simplified all the calculations. But there is some, you can say, the drawback, that the NRL method is only applicable to plain carbon steel and low alloy steel. So in plain carbon steel, you know that carbon is the major alloying element. And in plain carbon steel, there are 3 different types of steel: low carbon steel, medium carbon steel, and high carbon steel. And you already know that what is the carbon percentage range in all those steels. And then the steel can also be divided into alloy steel. So there are 3 types of steel: low alloy steel, medium alloy steel, and high alloy steel. So in low alloy steel, the alloying element, the total alloying element percentage is less than 5%. And so this method they have obtained, and they tried to implement on different materials, but they were successful in getting fruitful results only in case of vein carbon steel and low alloy steel. And there are certain modifications of this NRL method, like that there one of the team from this US Navy, they also tried and modified the curve for different materials like aluminum and magnesium, and they have also incorporated the some corrections related to the material and the shape of the casting. So, if you like the video, then please subscribe to my channel, share it with your friends, and don't forget to hit the bell icon for the latest updates. Thanks for watching my videos.